Welcome back to Spark tutorial at Learning Journal. In this session, I'll talk about Apache Spark architecture. We'll try to understand various moving parts of Apache Spark, and by the end of this video, you will have a clear understanding of many Spark related jargons and the anatomy of Spark application execution. Great, let's start. We already had an introduction to Apache Spark. I guess you learned enough to answer these simple questions. What is Apache Spark? Simple, a distributed computing platform, right? What do we do with Apache Spark? Again a simple question. We create programs and execute them on a Spark cluster, right? Now the question is this. How do we execute programs on a Spark cluster? There are two methods. Interactive clients and submit a job. I already showed you Spark installation, right? We accessed Spark using Scala shell, Python shell and Jupyter notebooks. All of these are interactive clients. That's the first method for executing your code on a Spark cluster. Most of the people use interactive clients during the learning or development process. Interactive clients are best suitable for exploration purpose. But ultimately, all your exploration will end up into a full-fledged Spark application, isn't it? It may be a streaming application, for example, reading a news feed as it arrives, and applying a machine learning algorithm to figure out that what type of users might be interested in this news. It may be a batch job. For example, my YouTube statistics. Every 24 hours, a batch job reads all the data collected during the period and computes the watch time minutes for that period. Finally, it inserts one record in some database, and I see it here. In both the cases, a long-running streaming job or a periodic batch job, you must package your application and submit it to Spark cluster for execution. That's the second method for executing your programs on a Spark cluster. For a production use case, you will be using this technique. Apache Spark comes with a Spark Submit utility. We'll learn more about it later, and I will show you various options and how to use Spark Submit. Great! We have an answer to the following question. How do we execute our programs on a Spark cluster? There are two methods, interactive clients and Spark Submit utility. We use interactive clients for exploration and Spark Submit for executing a production application. Now the next question. How does the Spark execute our programs on a cluster? Let me explain. Spark is a distributed processing engine, and it follows the master-slave architecture. So, for every Spark application, it will create one master process and multiple slave processes. In Spark terminology, the master is the driver and the slaves are the executors. Let's try to understand it with a simple example. Suppose you are using the Spark Submit utility. You execute an application A1 using Spark Submit, and Spark will create one driver process and some executor processes for A1. This entire set is exclusive for the application A1. Now you submit another application A2, and Spark will create one more driver process and some executor processes for A2. So for every application, Spark creates one driver and a bunch of executors. Since the driver is the master, it is responsible for analyzing, distributing, scheduling, and monitoring work across the executors. The driver is also responsible for maintaining all the necessary information during the lifetime of the application. Now, the executors. They are only responsible for executing the code assigned to them by the drivers and reporting the status back to the driver. Great! Now we know that every Spark application has a set of executors and one dedicated driver. The next question is this. who executes where? I mean, we have a cluster and we also have a local client machine. We start the Spark application from our client machines, right? So the question is, what goes where? The answer is simple. The executors are always going to run on the cluster machines. There is no exception to this. But you have the flexibility to start the driver on your local machine or on the cluster itself. You might be wondering that why do we have this flexibility? I'll explain that in a minute, but let me formalize this idea. When you start an application, you have a choice to specify the execution mode. And there are two options, client mode and cluster mode. The client mode will start the driver on your local machine, and the cluster mode will start the driver on the cluster. You already know that the driver is responsible for the whole application. If anything goes wrong with the driver, your application state is gone, right? So, if you start the driver on your local machine, your application is directly dependent on your local computer. You don't want that dependency in a production application. After all, you have a dedicated cluster to run the job, right? Hence, the cluster mode makes perfect sense for production deployment. Because after Spark submit, you can switch off your local computer and the application executes independently within the cluster. On the other side, when you are exploring things or debugging an application, you want the driver to be running locally. If the driver is running locally, you can easily debug it, or at least it can throw back the output on your terminal, right? That's where the client mode makes more sense over the cluster mode. And hence, when you start a Spark shell or any other interactive client, you would be using a client mode. So, if you are running a Spark shell, your driver is running locally within the same JVM process. You won't find a separate driver process. It's only the Spark shell. And the driver is embedded within the shell. Great. We have an answer to the following question. How does the Spark execute our programs on a cluster? You learned the answer. Spark will create one driver and a bunch of executors. If you are using an interactive client, your client tool itself is a driver and you will have some executors on the cluster. If you are using Spark Submit in cluster mode, Spark will start your driver and executor on the cluster. Now the next question, who controls the cluster? And how Spark gets the resources for the driver and the executors? That's where we need a cluster manager. As on the date of recording, Apache Spark supports 4 different cluster managers: Apache Yarn, Apache Mesos, Kubernetes, and Standalone. Yarn is the cluster manager for Hadoop. As of date, Yarn is the most widely used cluster manager for Apache Spark. Apache Mesos is another general purpose cluster manager. If you are not using Hadoop, you might be using Mesos for your Spark cluster. Kubernetes. I won't call it a cluster manager. In fact, it is a general purpose container orchestration platform from Google. Spark on Kubernetes is not yet production ready, but the community is working on it. Finally, the Standalone. This one is a simple and basic cluster manager that comes with Spark and makes it easy to set up a Spark cluster very quickly. I don't think you would be using it in a production environment. No matter which cluster manager do we use, primarily, all of them delivers the same purpose. Let's take Yarn as an example to understand the resource allocation process. I hope you are familiar with the Yarn application process flow. If not, I have an excellent video of Apache Yarn. Check that out. Okay, we haven't started coding Spark application yet. So you might not be aware that the Spark application begins by creating a Spark session. That's the first thing in any Spark 2.x application. If you are building an application, you will be establishing a Spark session. If you are using a Spark client tool, for example Spark Shell or PySpark, they automatically create a Spark session for you. You can think of a Spark session as a data structure where the driver maintains all the information, including the executor location and their status. Now, assume you are starting an application in client mode, or you are starting a Spark Shell, right? In this case, your driver starts on a local machine, and then as soon as the driver creates a Spark session, a request goes to Yarn Resource Manager to create a Yarn application. The Yarn Resource Manager starts an application master. For the client mode, the application master acts as an executor launcher. So the AM will reach out to Yarn Resource Manager and request for further containers. The Resource Manager will allocate new containers, and the application master starts an executor in each container. After the initial setup, these executors directly communicate with the driver. That's it. Great. So this is how Apache Spark creates a driver and executors for a client mode application. The process for cluster mode application is slightly different. In the cluster mode, you submit your packaged application using the Spark Submit tool. The Spark Submit utility will send a Yarn application request to the Yarn Resource Manager. The Resource Manager starts an application master, and then the driver starts in the AM container. That's where the client mode and cluster mode differs. In the client mode, the Yarn AM acts as an executor launcher, and the driver resides on your local machine. But in the cluster mode, the Yarn AM starts the driver, and you don't have any dependency on your local computer. Okay, once started, the driver will reach out to Resource Manager with a request for more containers. Rest of the process is same. The Resource Manager will allocate new containers, and the driver starts an executor in each container. Great. We covered how Spark runs on a cluster. We learned that we have two options: client mode, cluster mode. There is a third option as well, the local mode. You can also start a Spark application in the local mode. What is that? When you don't have enough infrastructure to create a multi-node cluster, but you still want to set up Apache Spark, maybe just for learning purpose, you can use local mode. The local mode is the most comfortable method to start a Spark application. In this mode, you don't need any cluster, neither Yarn nor Mesos, nothing. You just need a local machine and the Spark binaries. You start a Spark application in local mode. It begins in a JVM, and everything else, including the driver and the executors, runs in the same JVM. I showed you a Spark installation in very first video. That demo uses the local mode installation. The local mode is the most convenient method for setting up a quick learning environment. Great. I talked about 5 things: the driver, executors, client mode, cluster mode, and local mode. Do you want to see them visually? Sounds interesting? Let me show it to you. Let's start with the local mode. So, here is my machine. This machine is the one where I installed Apache Spark in the first video. Since I haven't configured Yarn or Mesos or even a standalone cluster manager, all I can do here is to start a Spark application in local mode. I'll show you both the methods: an interactive method using the Spark shell, and fire an application using Spark Submit utility. But remember that both of these are going to start an application in local mode. Client mode and cluster mode is only applicable on a cluster. But in this case, we don't have a cluster at all. Let's begin the shell. Let's look at some of these messages. Spark Web UI. Okay. Every Spark application offers a web UI for monitoring and tracking. For this application, Spark Web UI is available at localhost and port 4040. As I said earlier, Spark Shell has already created and started a Spark session, right? Now, let's go to the Spark UI. Click on the event timeline. It says executor driver added. That means there is only one process and it is acting as an executor and the driver both. That's what I expected about a local mode application. Everything runs inside a single JVM. I'll exit the application and refresh the Spark UI. It's gone. This UI exists only for the life of the Spark application. You can get it again from the Spark history server, but let's leave the history server for another video. Now, let's start an application using Spark Submit utility. I'm using an example that comes along with the Spark. This example approximates the value of pi. The first parameter is the name of the main class, and the next parameter is the example's jar file. Finally, I am passing an argument to the main class. I am using 1000 slices to make sure that the application runs for a while. Started. Let's go at the Spark UI. Okay, the processing of these many slices is complete, and we see only one executor driver. You can't expect anything more from a local mode, right? So, we have seen local mode. Now it's time for a client mode and the cluster mode. We'll need a cluster environment. I've set up a 4-node Hadoop and Spark cluster in Google Cloud. If you are interested in trying it yourself, check out my Google Cloud tutorials. You can set up a free Hadoop cluster in Google Cloud. Okay, here is my cluster. I have one master node and 3 worker nodes. Each worker machine has got 2 CPU cores, and hence I have 6 Yarn cores available at my disposal. Here is my Yarn Resource Manager UI. You can see that there is no application running on this cluster. I am going to repeat the same exercise as we did for the local mode. Start an interactive client using Spark Shell, and then fire an application using Spark Submit utility. The first one is a client mode and the second one is going to be a cluster mode application. Let's SSH to one of these nodes and start a Spark Shell. The Spark Shell will start one Spark application in client mode. Then we will see how the driver and the executors are getting started on this cluster. Good, started. Let's reach out to Spark UI using Yarn Resource Manager. Refresh the Yarn Resource Manager page and you will see an application link, right? Go to the tracking UI and hit the application master link. Great! The Yarn started these many executors, but soon it removed all of them except one. That's because of the dynamic allocation feature of Yarn. Since we are not doing anything and the executors are idle, Yarn has released all of them except one. Let's close this Spark shell and start a new one. This time, I want to specify the number of executors explicitly. Now, I expect that Yarn should begin with 3 executors. Here is my new application. Let's check. Great! 3 started and 2 are released. Where is the driver? Click on the executors page and you will see some details. The driver is running on the master node. This is where I did the SSH. So the driver started on my local computer. There were 3 executors, one on the node 0, another one at node 1, and finally the third one at node 2. 2 of them died and this one is still active. We have seen client mode. Amazing, isn't it? Let's start an application in cluster mode. The command is same as I used earlier, but this time I'm explicitly specifying the deploy mode parameter. Let's start it. Great, it is running. Let's go and check the UI for this application. So, we started these many executors. Let's review the driver. I used Spark Submit from my master node, and the driver is running on one of the worker nodes. That means the driver is also running in the cluster, and it has no dependency on my local computer. Great! It was a long session. We learned and explored many things, but this doesn't end the Spark architecture discussion. I need at least one more video to deep dive further into Apache Spark architecture and explore following. How does the Spark breaks our application into smaller parts and get it done at the executors? That's what the topic for the next video. Thank you for watching Learning Journal. Keep learning and keep growing.